Hello! In this video I will show what ROS arguments are and how to use them from the command line with the ros-args flag, and how they can modify some aspects of our ROS node in our ROS network. Hello, I'm Roberto from the Construct. I will be using the Construct's platform to program robots. You can use it too by going to theconstructsim.com and create an account. I will log in into my account and show you the ROS-ject that I have prepared for this video. So it's this one. And you can have a copy of this ROS-ject by following the link on the description of this video. Let me open this here, the code editor, web shell, and my nodes. So basically you can build the workspace. I already did it. So let's execute the simulation first. I go to this directory that you see there on the right side on the instructions, and execute this script that will start the simulation with the robot, which I will need to show some of the examples. So what do we mean by ROS arguments? Here you can see the robot in the simulation. It's the white square down there. So let me first run a node, an obstacle avoidance node, without any ROS arguments, just a plain node. It will cause the robot just to turn in place at the current position. That's all it's doing. But let's have a look at the nodes that we have currently running. So we have the obstacle avoidance node, and there's a camera driver, gazebo, robot state publisher, and the different plugins from the simulation. Okay, let's look at the topics. So we have the camera topics, the command velocity topics, IMU, odometry topics, robot description, laser scanner topic, NTF topic, and some others. This is what's the standard when I just launch or run this node unmodified. But now I will show you how we can modify it by using ROS arguments, some of these aspects. So here I just run the exact command where I type ROS2 run the package and the executable, then followed by 2 dashes ros-args. This indicates that what is following after this flag ros-args are ROS arguments, and they will modify how the node is or appears in the ROS networks. In this case, I'm starting the node in a namespace. So I use the _NS, and then I can set namespace. In this case, I'm setting namespace robot1. Just let me execute both commands that I did before using now that the node is running on a node in a namespace. So we can see the obstacle avoidance node is now running under the namespace robot1. Before it was like here, you can see on the top, not inside a node namespace. And let's see the topics. The command velocity topic and the scan topic are inside the robot1 namespace. These are the topics that the obstacle avoidance node is subscribing to. You can see there's also a scan topic here without a namespace, and the command velocity topic without the namespace. These are the nodes that are being, the topics that are being published by the robot, or in this case by the Gazebo plugin. So you can see they are not communicating each other, because one is subscribing with a namespace prepend to it, and the other one is publishing without the namespace. But what I wanted to show you is how to use ros-args to prevent a namespace to a node when launching from the command line. So what I want to show you next is, well, before I show you this, why would you like to maybe prevent a namespace? Because you can launch the node 2 times or multiple times if the namespace and the name of the node are different. Then you can have a multiple instance of a node running. In this case, I could run the obstacle avoidance node for robot 1 and the obstacle avoidance node for robot 2 if they are in different namespaces, so they don't collide. So what I can also change the name of the node when I'm launching it from the command line with the ros-args dash remap, and then I specify the node name. Actually, I think this is without the remap. Let me check it. No, it has to be with the remap. So it's exactly like here. So you use ros-args dash remap underscore node and the name of the node, the new name of the node. So you can already see here on the log that it's under the name collision underscore avoidance. And if I run ROS2 Node list, the node name is now collision avoidance and not obstacle avoidance as before. So you can use ROS arguments to change the name of the node. Now I will do remapping. Remapping, which means changing the topic name, and you do it by running ros2 run your package and your executable name. You use the ros-args flag -r, the current name of the topic and the new name for the topic. In this case, I am changing from scan, which is the standard, to laser scan. Let me do the remap here. So I launch the node, and now I do a ROS2 topic list, and I can see there's a laser scan topic, which is the obstacle avoidance node, which is subscribing to laser scan topic because I did the remap. This scan topic here is the scan topic being published by Gazebo. So what else can we do with ROS arguments? I can set parameters. I can use it to set parameters. So by using ROS ros-args -p, I can set a parameter value when starting a node from the command line. So let me retrieve the parameters. Obstacle avoidance node has angular velocity z, angular velocity x, angular x velocity, angular z velocity, and safety distance as the parameters. The other are quality of service parameters. And let me get the value ros2 get it's right here. The value is 0.5, which is the value for safety distance parameter that I set here when I started the node. So if I start the node without the setting a parameter, it will have default values, and the default value for this parameter is 2.0. So there you go. This is how you set parameters for a node using ros-args. And the last feature I want to show you is how we can set the logger level using ros-args. So you use --ros-args followed by --log-level, and then you set, in this case I set the level to debug, but it could be info or warning or fatal. So now I started in the node, so now I got lots of print statement. Those in green are all the debug print statement that I included in the source code of this node, and only one info, which is also printing here when the node starts. So using ros-args, you can easily debug or launch a ROS node with debug print statement to see whatever data you want to have printed out to the console. And when you're done, you just don't use it and start the node as usual, and it will not print the bug statement. Very handy. Let me close everything, simulation, to show you the courses that we have here on the construct. If you go here from the home screen to courses, you will have a list of courses that you can start for learning ROS and ROS1 and ROS2, and have a look at the different courses. Maybe there's something that you're interested in. If you're new to ROS, I would recommend starting with ROS Basics in 5 days. Either this is ROS1, either for Python or C++, and the same course is also for ROS2 available. So ROS2 Basics in 5 days. And that's it for today's video. If you liked it, give it a thumbs up or share it with friends, and see you in the next video. Bye.